All right, let's talk long division. What is long division and why do we use it? Let's go from there. So I'm going to start by writing down a division fact. 6 divided by 2 equals 3. Now, we know our multiplication facts and division facts, hopefully, which means that if we are given a problem like 6 divided by 2, we just know from memory that the answer is 3, just like we know that 2 times 3 equals 6 because we've hopefully learned our multiplication facts by memory. Now, just like with multiplication, when we are dealing with larger numbers, we have to do a few more steps to get to the answer. So if I had 356 times, 518, to get to the answer, we have to do more steps. And that was just me setting up a multiplication problem using standard algorithm. And it's the same with division. With division, we have to do a few more steps when dealing with larger numbers. And the way to best learn those steps is to practice and practice and practice, which we're going to do. Now, just like multiplication, when we're working with larger numbers, with long division, there are different methods to solving long division problems. In this video, we are going to do standard algorithm long division, which is one way to solve a long division problem. I have another video on partial quotients, which is another way. And I also have another video on box division, which is another way to do long division. But right now, we're only going to work with the standard algorithm for long division. So the first thing we have to know when doing a division problem, we have to know division terminology. So, you know what, I'm going to write this down a little bit larger. Let's even change the problem. Let's do 8 divided by 2 equals 4. Now, in division, in any division problem, the number that is being divided is called the dividend. The number that we are dividing by is called the divisor. And the answer to a division problem is called the quotient. So we have these names, and it is important that you know these names because we are going to be using them frequently. Sometimes I notice my students will do something like, they'll say something like, 8 and 2 are the factors and 4 is the product. No. That's the case when we have a multiplication problem. So if I had 2 times 4, 2 and 4 are factors with 8 being the product. That's terminology for multiplication. But with division, we have dividends, divisors, and quotients. And it's especially important to know that when we are setting up a division problem. This is how we set up a division problem. This is from one of my reference sheets. We put the dividend, that's the number that gets divided, inside of this shape. It's kind of like a sideways 7, this shape over here, kind of like a rotated 7. Another way that people write this sideways 7 is they sometimes also make it kind of like a backwards C. You might see it like this, 450 divided by 5. And as you can see, this is kind of like a backwards C. And it doesn't matter. You can do it any way you want. But this is the standard algorithm setup for long division, where you put the number that's being divided, which is the dividend, inside the 7. Now, one way that I teach kids is the number that's inside of the dead end is the dividend, and they both have the word end in it. A dead end, as you know, is is the same as a cul-de-sac. It's a road that doesn't connect to another road. So I often say the dividend it's the number that goes in the dead end. It's the number that's being divided. And then the divisor is the number that we're dividing by, and the answer is the quotient. Now, let's solve this problem. Now, there are a lot of steps to long division. There are a lot of steps to long division using the standard algorithm. And it's one of those things that you just have to learn it and practice and practice and practice until you get it and it comes naturally. I personally tell my students that they can use this method or any other method, but I want them to know this method because I think oftentimes it's the fastest. I don't know, that's debatable. The only thing about using the standard algorithm method is that I do think it is the hardest one to learn. So let's solve this problem. You know what? The answer's already there. Let's solve a different problem. Let's do 361 divided by 5. Let's do that. All right. I'm going to go through these steps one by one. So the way to solve a long division problem, we use these steps: divide, multiply, subtract, bring down. The last step is repeat or remainder. And we'll talk about what that all means. Now that's a lot of steps. Divide, multiply, subtract, bring down. And you might be saying to yourself, I don't even know what that means. Another way to think of divide is I tell my students it can also mean go into. Let's go through these steps one by one. And again, it's a lot to take in, but we're going to practice. At least in my class, we're going to practice a lot. Let's do it. So the first thing I'm going to do is I'm only going to look at this first number, and I notice it's a 3, and I say, how many times does 5 go into 3? In other words, 3 divided by 5 equals question mark. But guess what? You can't divide 3 by 5 and get a whole number. It doesn't work because 5 is greater than 3. So what I'm going to do is jump over to the next number. And now I'm going to say, well, how many times does 5 go into 36? 36. So I'm going to ignore that 1. And I'm going to say, how many times does 5 go into 36? And I know that 5 goes into 5. And then one method is you can use your multiplication chart. I know my multiplication facts, so I know that 5 times 7 is 35, and that's the right number. But what some kids will do is they'll go 5 times 1, 5 times 2. They'll just write out their facts on the side here. So we'll say equals 5, equals 10, equals 15, equals 20. Okay, I'm still not there yet. 5 times 5 equals 25. Let me move over. 5 times 6 equals 30. Okay, I'm getting closer. 5 times 7 equals 35. Oh, that's pretty close. And then I'll say 5 times 8 equals 40. Too big. We don't want it to be too big. It has to be the closest number to 35 without going over. So the factor I'm looking for is 7. So I'm going to put a 7 right above the 6. Very important that I don't put the 7 above the 3. It's going to mess up these steps of divide, multiply, subtract, bring down, repeat or remainder. What I have to do is put the 7 over the 6 because I'm checking how many times does 5 go into 36, not into 3. Okay, so I've done that. I'm going to erase this. We don't need that. We figured that out. So I did my divide part. I said, okay, 36 divided by 5 is 7. Now I multiply. I'm going to multiply 5 times 7. What is 5 times 7? Well, we already know. We did it. It's 35. Let me remove this black line there. So I say 5 times 7 is 35. So I did the multiply. And now I need to subtract. So I subtract 35 from 36. That's the next step. 36 minus 35 is just 1. So I did subtract. Now we have this interesting step called bring down. What am I bringing down? Well, I look to the number to the right of the number we just divided, which was 36, and I bring this number down. I bring down the 1, which gives me the number 11. Okay, so I did bring down, and now for this last step, it's repeat or remainder. Repeat or remainder. How do you know whether or not to repeat the problem? Well, if the number that we have down here is greater than our divisor, we keep going, we repeat. 11 is greater than 5, so we repeat. It's only when the number down here is less than the divisor that becomes our remainder. Again, I know this is a lot of information, but we're going to practice a lot. So now we're on the repeat step. So what do? Instead of looking at the dividend and saying, okay, what is 36 divided by 5? I'm going to actually look at this number. What is 11 divided by 5? Another way to think about it is go into. How many times can 5 go into 11 without going over? So, one way, if you want to do it this way, you can do it this way. You can say, okay, let's see. I know 5 times 2 equals 10. That's pretty close to 11. And I know 5 times 3 equals 15, but 15 is too big. We can't do that. So it's going to be 2. So then I say, okay, 5 goes into 11 2 times. So I did divide again. I did the repeat and I do divide again. Now I go through the same process all over again. And you'll notice that I'm putting these little check marks next to the steps. I often tell my students to do that because I think it helps them keep track of where they are. So we're now going to go through. We have a second check mark. Oopsie doopsie. We have a second check mark now next to divide. We're on that step and we just completed that step. Now we got to multiply. We're going to multiply 5 times 2. 5 times 2 is 10. So we did our multiply step. Now we got to subtract. 11 minus 10, well, that's 1. So I did my subtract step. Bring down. Well, there's nothing to bring down. There's nothing here. We're not working with decimals yet, so there's nothing to bring down. And now it's repeat or remainder. So I'm going to look at this number over here. How do I know if I repeat or if it's a repeat? I repeat the process, or if it's a remainder? Well, I look to see if 1 is greater than or less than the divisor, which is 5. 1 is less than 5. 5 cannot go into 1, which means 1 is our remainder. Let me put a little remainder. You can think of it as the thing that's remaining, that's left over. And now we can say, the way that we would write this is we would say 72 R1. 72 with a remainder of 1. That's our answer. And if you specifically want to know what this one would be as a fraction, it's actually 1. Oopsie, that's not the color I wanted. It is actually 1 over the divisor, which is 5. So 1/5. So our answer is actually 72 remainder 1. Or if you want to get very specific, it's 72 and 1/5. Also can be an answer. Are we having fun yet? I know, like I said, it's a lot of steps. And the only way to learn standard algorithm, I think, with long division is just practice it a lot and allow yourself to make mistakes because there are a lot of steps. Let's do another problem. Let's do, how about 78, a 2-digit number, divided by 3. Let's do this problem together. Okay, so the first thing I'm going to do is I got to think about my steps. It's divide, multiply, subtract, bring down, and then repeat or remainder. And the kids in my math groups, we do a little rhyme to remember this. It goes like this. Divide, multiply, subtract, bring down, repeat, or remainder till the quotient is found. And so that's one way that we remember it. Again, it goes like this. Divide, multiply, subtract, bring down, repeat, or remainder till the quotient is found. So whatever works, right, guys? So let's now follow the process. So the first thing I'm going to do is divide. I'm going to divide, which we also call go into. Go into. Sorry, my handwriting is not the best. how many times does 3 go into 7? Or how many times, or sorry, what is 7 divided by 3? But we can think of it either way. Well, I know that 3 can go into 7 2 times. Let's do 2. And if you're not sure, remember, you can write it down. 3 times 1 equals 3. 3 times 2 equals 6. 3 times 3 equals 9. That one's too big, so it's got to be this one, right? So 3 times 2. So we did our divide step. Now we're going to do our multiply step. 3 times 2, that equals 6. We did multiply. Now we subtract. We did our subtract step. Now we bring down. Now, some teachers don't like this arrow. They think it's confusing. I do like it because I think it helps kids keep track of where they are, even if you need to do it maybe like faint. But I do use it. Bring down. So we did the bring down step. 3 goes into 18 6 times evenly, so we're not going to have a remainder. So, so we do now this. So 3 times 6 is 18, subtract 0. Repeat or remainder, well, we don't have a remainder. We don't need to repeat the process. The answer is just a simple 26. Sometimes students write 26 remainder 0, but if there's no remainder, it's fine just to write 26. I'm going to stop there. I know in my group we're going to work on this a lot. We're also I let my students choose between traditional standard algorithm long division, partial quotients, or box division. But for now, we'll stop there. Until next time.